question of whether staple sizes should be changed to match new non-metallic cable sizes is a pertinent one in the electrical trade. The argument stems from the observation that staple sizes have remained relatively constant for many years while non-metallic cable dimensions have evolved. This discrepancy leads to situations where some staples are too small, some are too large, and finding the right fit can be challenging. Let's examine the potential benefits and drawbacks of changing staple sizes. Firstly, improved compatibility would be a significant advantage. Staples designed specifically for new non-metallic cable sizes would fit securely, ensuring a code-compliant installation. This eliminates the guesswork and adjustments often required with current staples. Secondly, enhanced safety is another key consideration. Properly fitting staples reduce the risk of cables slipping out or becoming loose. Loose cables can create electrical hazards, so secure stapling is crucial. Thirdly, reduced material waste is a potential outcome. Fewer staple sizes would eliminate the need to purchase multiple sizes to accommodate different cable diameters. This streamlines inventory management and reduces waste. Fourthly, time savings could be realized. Electrical contractors could use the correct staple size for the cable immediately. This reduces time spent on adjustments and minimizes frustration on the job site. Now let's consider the potential drawbacks. Firstly, compatibility with existing installations poses a challenge. Staples from different manufacturers and sizes may not be interchangeable. This would require the replacement of existing staples in older installations, which could be a significant undertaking. Secondly, industry disruption is a concern. Changing staple sizes could cause confusion and disruption in the electrical industry. Contractors and electricians would need to adjust to the new dimensions, which could lead to errors and delays. Thirdly, increased costs are a potential downside. New staple sizes may require new production processes. This could lead to higher manufacturing costs and, ultimately, higher pricing for consumers. Fourthly, limited demand might exist for a change. Many contractors and electricians have adapted to using existing staple sizes with slight adjustments. Therefore, the perceived need for change may not be widespread. Looking at the current market situation, the electrical industry has indeed been using the same staple sizes for non-metallic cables for decades. While some manufacturers have introduced slightly larger sizes to accommodate the increased insulation thickness of larger gauge cables, the overall staple sizes have remained largely unchanged. Considering these factors, there is merit to the argument that staple sizes should be revised to match the new non-metallic cable sizes. However, it is crucial to consider the potential challenges and disruption that such a change could bring. A more pragmatic approach could be to encourage manufacturers to provide a wider range of staple sizes to better accommodate the variations in non-metallic cable diameters. This would allow contractors to choose the most appropriate staple for each specific installation, without the need for significant changes to the overall staple size system. This approach allows for flexibility and addresses the need for better fit, while minimizing the disruption and cost associated with a complete overhaul of staple sizes. In detail, considering the improved compatibility using staple sizes that match new non-metallic cable sizes ensures a secure fit around the cable. This eliminates the need for excessive force during installation. Such force can damage the cable insulation and lead to electrical faults. In terms of the safety enhancement, the proper fit minimizes cable movement within the staple. This prevents abrasion and potential damage to the cable insulation over time. Damaged insulation can expose live wires and create a risk of electric shock or fire. Regarding reduced material waste, rationalizing the number of staple sizes needed for different cable gauges can reduce the amount of unused staples. This contributes to more efficient inventory management and minimizes the environmental impact of manufacturing and disposal. Furthermore, considering the time savings, selecting the correct staple size becomes quicker and easier. This reduces the time spent searching for the right staple and making adjustments. This improves productivity and reduces labor costs on projects. On the other hand, If we consider the compatibility with existing installations, any change to staple sizes would require careful consideration of how the new staples would interact with existing wiring systems. Older installations may have used staples that are no longer compatible. It is also important to ensure that any new staples are compatible with the materials used in older wiring systems to prevent corrosion or other adverse reactions. Discussing industry disruption, a significant change in staple sizes could disrupt existing workflows and supply chains. Contractors and electricians would need to be trained in the new sizes. Distributors would need to stock new inventory. This transition period could lead to delays and increased costs. When it comes to the potential for increased costs, the cost of retooling manufacturing processes to produce new staple sizes could be substantial. This cost could be passed on to consumers. There's also the cost of disposing of existing staple inventory and purchasing new inventory. Addressing the concern over limited demand, it's important to assess the level of support for a change in staple sizes among contractors and electricians. If most practitioners are satisfied with existing staple sizes, there may not be sufficient demand to justify the costs and disruption associated with the change. In greater detail regarding market saturation, the market is already saturated with existing staple sizes. Introducing new sizes could create confusion or make it more difficult for contractors to source the staples they need. The transition from old to new sizes would need to be managed carefully to avoid disruptions in the supply chain. Manufacturers would also have to invest in new tooling and equipment to produce the new staple sizes. This investment could be significant and could increase the cost of staples for consumers. Furthermore, a gradual transition could also lead to confusion. Some contractors might use the old staples while others use the new staples, potentially leading to inconsistent installations. A clear timeline and communication strategy would be necessary to ensure a smooth transition. Moreover, if the new staple sizes are not significantly better than the existing ones, contractors may not see the value in switching. They may prefer to stick with what they know and are comfortable with. The benefits of the new staple sizes would need to be clearly demonstrated to convince contractors to switch. It is also crucial to consider the environmental impact of changing staple sizes. The production of new staples would require resources and energy. Disposing of old staples would also generate waste. A thorough life cycle assessment would be needed to determine the overall environmental impact of changing staple sizes. In addition, if the new staples are not compatible with existing staple guns, contractors would need to purchase new tools. This could be a significant expense, especially for small businesses. The cost of new staple guns would need to be factored into the overall cost of changing staple sizes. Compatibility issues with existing staple guns could also lead to frustration and delays on the job site. Contractors might have to carry multiple staple guns to accommodate different staple sizes. As the old staple sizes gradually phase out, the older staple guns would become obsolete, adding to the overall cost. The transition would also necessitate revisions to training materials and apprenticeship programs. Instructors would need to update their curriculum to reflect the new staple sizes and installation techniques. Apprentices would need to learn how to use the new staples and staple guns. This could require additional training hours and resources. There would also be a need to update codes and standards to reflect the new staple sizes. This process can be lengthy and complex, involving multiple stakeholders. The code update process could also create uncertainty and confusion in the industry. A clear and consistent message would be needed to ensure that everyone understands the new requirements. It's also worth considering the potential for innovation in staple design. Instead of simply changing the sizes of existing staples, manufacturers could explore new designs that offer improved performance or ease of use. For example, staples could be designed with a special coating that reduces friction and makes them easier to drive into wood. Or, staples could be designed with a wider head that provides better holding power. These innovations could make staples more effective and efficient, regardless of their size. Another approach could be to develop a universal staple gun that can accommodate a wider range of staple sizes. This would eliminate the need for contractors to carry multiple staple guns. A universal staple gun could also be designed to automatically adjust the driving force based on the size of the staple. This would prevent overdriving or underdriving the staples. This approach focuses on making it easier to use staples rather than simply changing their sizes. By considering the pros and cons and market conditions, it's possible to see the real implications and the cost versus benefit of such a change.